Okay, welcome back. We're going to go ahead and start phase 3 of our JavaScript tower game, and I'm going to talk a little bit about what we are going to be covering in this next series of videos. First of all, we're going to talk sort of throughout about what the difference is between, or how do we make objects in JavaScript. Technically, there are no classes in JavaScript. So in Java, for instance, or in C++, we create a class which works as a kind of a template, and from that class, we make objects. But in JavaScript, there are no classes, even though we've been using the class keyword, and I'm going to talk about what that means and why we do that. I'm going to talk about how some objects can inherit from other objects. I'm also going to talk about, we're going to create a vector class. I think we'll start off with this video. I'll talk a little bit about vector math. I'm going to show two different ways to do it, with one using prototypes and the other is using the class syntax. But in either case, we'll get a view of how to do this in JavaScript, how to create vectors, and then all the methods that are associated with them. Also, we're going to do two things regarding paths. We're going to have path following and path finding. It seems like we do path finding first, but actually path finding is fairly difficult. Path following is actually not so difficult. We're just using three vectors: a location vector, a velocity vector, and an acceleration vector. So velocity is just change in location, acceleration is change in velocity, and so we'll be using vectors to move our pieces around the canvas. But then finding a particular path is a little bit more challenging, and there are lots of different algorithms we could look at. I'm going to look at least two. A-star is really popular, although it's fairly complicated. Goal-based pathfinding, I think, is the easiest. I would say the easiest by far. It has some advantages and disadvantages, and so we'll probably spend one or two videos on pathfinding. So that's what we're going to be covering in this next series. By the time we get done, we'll have enemies that are following a path from one point to another within the canvas area. Let me show you some things my students did first semester using these vectors. Okay, so these are some projects my kids were doing last semester, and this is all actually out of a book called The Nature of Code by Daniel Schiffman. I strongly recommend it to you, but all these little creatures are being moved around with vectors. So there's a snake that's gobbling up these little animals. This is a pathfinding project we did. No matter where these snakes spawn in this grid, they're always going to this 0 point, and so right now there's no obstacles in here, but we're going to put that in later. And here's one where we have a snake. These guys are flocking together, and the snake is trying to gobble them up, and we can see that the snake is pushing them away, or they're running away from the snake, and so forth. This one's interesting. This is an ecosystem. Those two just had babies. This guy's firing things. This is a student who really took off with this. I think there's about 2,000 lines of code in this one project, but those are the kinds of things the students are doing with vectors, moving things around in nice flowing movements. Again, Daniel Schiffman, The Nature of Code. Oh, this young lady put some of our lessons into a single web page, and she can turn them off and on. So she has particle systems, again using vectors, flocking using vectors. The snakes are trying to go around and gobble up the flock members. We have attractors and repellers, and we just have these balls bouncing around. Okay, I haven't taught math in about 10 years, but we used to teach vectors in pre-calc, I think, and maybe just pre-calc, obviously in calculus, but in any case, at the high school level, I think it's sort of fallen out of fashion. Maybe it's a little bit in physics, but when I talk about vectors with my kids now, most of them, even the advanced math kids, don't have much familiarity, but there's very little we have to know. Basically, what is a vector? The two things we're concerned about with a vector are, first of all, a vector looks like, when we draw it, it looks a little bit like a ray. I'm just going to say this is vector A, and this vector, sometimes people put a little vector on top of it. But anyway, I'm going to go ahead and say vector A, and there's two things that we're concerned about with this vector. The first thing is we want to know what the angle is, so let's call this theta, and the second thing is we want to know the length, and we're going to call the length the magnitude. Okay, so the magnitude and the angle, we don't really care where this is in the plane. A vector really just has those two values. Its particular location isn't important, and so we want to know how to add two vectors together and how to subtract one vector from another. So first of all, let's think about vector addition. If I have a vector A, and I'm going to add to that another vector, let's go ahead and make a pretty green vector, and let's say this is vector B, and I want to add those two together, I am going to simply think about this as moving these guys head to tail like that, and then I'm going to come up with a resulting vector. And the resulting vector, when I add these two together, is going to be from the tail of A to the head of B. So this is now A plus B. Okay, so if we know how to add two vectors together, if we add A and we add B together, we're going to end up with this new A plus B vector. And we can apply that same thinking to subtraction. If you think about, if we have A, which is this guy, and we have B again, let's do him again in green, and so this guy over here is my B vector. And so if I think about taking this guy and moving him over here, that would be A plus B would be adding those two guys together. But what I can do is I can think about this in terms of negative B would just be moving in the opposite direction. And so if I wanted to take now A plus negative B, that would be from the tail of this guy. So I'm saying A plus negative B, which is the same as A minus B, would be that guy. So how does that help me? Well, it turns out if I thought about these two vectors as being location vectors, let's think about B back down here for a minute, and then I thought about A minus B. A minus B is going to be this guy. So let's see if I can squeeze around there, grab him, and move him over. If I drew these just right, I would get that. And so how does that help me? It turns out that if I'm looking in my canvas area and I've got one guy, let's call him M1, I've got another guy over here, M2, and I've got this vector and I've got this vector, they're location vectors. If I want to find the vector that points between them, that's this guy, that's going to be the location of M1, so I'd say M1.loc minus M2.loc, and that's going to give me a vector between my two things. So I'm going to use this when I want to, let's say I've got my vector here and he's moving in some direction. If I want to start steering him towards that, I get this vector and I just start applying a little bit of it. I shrink it down and I start applying a little bit of force, and this guy will gradually start turning towards the direction I want to move. And so that's how I'm going to use vectors. That's about all you need to know about vectors for this project. Okay, so now we're just going to pick up where we left off in the last video, and we're going to go ahead and make a, let's see, we're going to make a new vector class. First of all, I just want to mention that this guy, Vector.js, this is a vector class that my kids made last semester, and I think there's some things missing in there. Actually, I can see a couple of methods it doesn't have, some sort of intermediate version. In any case, this syntax is different than what we've been using. I specifically did this with my kids because I wanted them to work with this idea of a prototype. I'm going to talk more about that later, but I'm going to go ahead and make a brand new vector class right now. And the vector class that I'm going to make is going to be just using the same syntax we've been using throughout the game. So I might talk about the prototype at some point. Maybe we'll make a vector using JS vector. I'm going to create a brand new file. I'm going to say, let's go ahead and save this as, and I'll put this in the same folder. So I'm going to come into, let's see, libraries. I can see I already have two vector classes in here. I'm going to have to name this something else. So I'll say jsvec.js. And so this is going to use accomplish everything this class does, but it's going to do it in a with a different syntax. And so maybe the easiest way would be just to open up my bullet class and to copy all of this and to just dump it in here. And now this is going to be JSVec, and I'm going to get rid of all of this stuff. I'm going to get rid of this. And I'm going to get rid of, let's see, run, update, and render. I'll get rid of all three of those. So basically, I just have this new class. I'm using the word class. This, again, is a new keyword in the latest version of JavaScript. And it's just supposed to make Java and C++ programmers feel more comfortable, I think, because there are no classes in Java. And so this is actually called syntactic sugar. It basically allows you to write as if there were classes, and then this gets all sort of transpiled, I guess, back into JavaScript. But in any case, this works fine as long as I'm using this use strict up on top. I can use the class and I can use a constructor here, and the syntax you're going to see is quite a bit different, quite a bit simpler, I think. And so the only two variables that I'm going to pass in here are an x and a y parameter, and so I need to set those up in here. So I'm going to say this dot x is equal to x, and likewise this dot y is equal to y. Okay, and now I'm just going to make some methods, and I'm going to take these same methods that I made over here. And talk about the prototype. We'll take a look. We'll create a JS vector object, and we'll create a JS vec object, and we'll look at the difference, and we'll see what this prototype is, this word prototype, what it means, why it's being used in JavaScript, and how prototype is how we create objects from other objects in JavaScript. In Java, we create objects from classes, but in JavaScript, anytime you make an object, it automatically gets a prototype, and that prototype has information in it that is going to be common to all objects created from any JS vector object. In any case, I'm just going to sort of mirror some of this code over here, and we're going to use our latest syntax. And so, for instance, if I want to do an add function, I'm just going to say simply add, and I'm going to make the function in here, and to add vectors together, you just add their components. And so add is going to take in some vectors, let's just call it vec for short, and to add these guys together, all I have to do is take this dot, actually I can just copy and paste this over, just like that, and notice I have this or 0, and so basically if vec.x is undefined, if somebody passes in, let's say they use the add without passing in a vector, or pass something else in other than a vector, it doesn't have an xy component, then it would just create a 0, 0 vector. If I do this, I don't have to do that. It would probably be better instead of doing that if I just threw an error, like for instance, if this guy does not exist, or if it's not a vector, then I can simply throw an error. But in any case, I'm not going to do that right now. So basically, I'm taking the x and y components of whatever vector I'm sending in. I'm adding the x component to this and the y component to this. So remember, I'm going to have a JS vec object, and if I say, let's say that object is v1, I can say v1.add and pass a vector in. It's going to take the x and y component of that vector and add it to whatever this is. And so that's basically what we're doing in all of these. So let's go ahead and do the same thing for subtract. If I subtract here, I can just say sub for short, and all I have to do is change this to a minus. So I can subtract, I can subtract the x components, and same thing. I'm subtracting the x and y components of this vector from the x and y components of whatever vector object this is. Okay, now add get new and sub get new. This is a little bit different, because when I just use sub here, notice I'm actually changing this x and this y value, and I want to have another vector. I'm going to call this add get new, so I'll get rid of that, and I'll get rid of all of that, and I think I'll change this so that I'm just going to pass in two vectors into this guy, so we'll call it vec1 and vec2. And so what I want to do is I want to take vec1.x and vec2.x and add those together. My phone just beeped. So let's just do that here. I'm going to say vec1.x minus vec2.x, and I'll do the same thing down here for the y value. And we'll just take the difference in y's. Okay, and so now I'm going to go ahead and create a new vec, and this guy is going to just take a new JS vec, which is my new class I'm working in right now. And so JS vec is going to take whatever x and y value these guys are. But the key thing here, when add get new, I'm adding the x components and the y components of two different vectors, and I'm returning a brand new vector. So if I do this, I can get a third vector. So I've got a location vector for, let's say, object 1 and a location vector for object 2. I can pass in their two location objects, and this is going to give me a third vector that doesn't harm or change either of the original two. And I'll need that when I start moving things around. So that's what I'm doing here. And then I'll do the same thing with sub get new. So same thing, except instead of adding these guys together, I'm going to subtract. So, I've already done subtraction. So let me change this to addition in add. I obviously want to be adding, and in subtraction I want to be subtracting. Sorry if that was confusing. Both cases, I'm going to be passing a new vec back. Okay. Get direction. Get direction is pretty simple. So I'm going to take this syntax. I'm just going to come over here and rewrite it. And so this guy, get direction, I'm going to shorten this. Let's say get dir. And so that's going to be my function. So get dir, if I have a vector object, I can say get dir, and it's going to return same thing we did earlier, atan2. The difference between atan, by the way, and atan2, both are in the math class. atan2 takes value above pi or negative pi radians. So atan2 was limited, and for games, it's just a lot easier to use atan2. In any case, this dot y and this dot x, if I pass those two values in to atan2, that will give me the angle in radians that this is pointing in. And we can test this out in a minute. And then we have get magnitude. So we have, remember, two values for a, oh, and I don't need a semicolon here. Let's get rid of that. And I've got two values when I deal with a vector. One is the angle and one is the magnitude. So get direction is going to get the angle in radians, and get magnitude is going to give me the length. And so to do that, all I have to do is use the distance formula. Assume one point has coordinates 0, 0. And so I create a variable x2, which is the this dot x times this dot x, this dot y times this dot y. So this is the Pythagorean theorem again. Remember math dot square root. And I'm taking this dot x squared and this dot y squared, and then I'm returning that value, and that's going to give me, if I pass in the distance, or if I want to get the magnitude of this particular guy. So if I have a vector and I say, let's say that vector is v1, I can just say v1.getMag, and getMag is going to return the magnitude of that vector. Okay. And so now I want to set the magnitude and set the direction. So let's grab these guys. I'm going to do the same thing over here. I'm just going to change the syntax a little bit. So this guy is going to be set direction, and I'm going to pass in a new angle. So I want to, wherever my angle is pointing, I don't want to change the magnitude, I just want to change the direction. So I can say, create a temporary variable called magnitude, and I'm going to get this dot get magnitude. Actually, I changed it to get mag, so let's go ahead and change this to get mag. And I'm passing in this guy, so if new angle exists, go ahead and use it. Otherwise, set x and y equal to 0. I'm not even sure that's reasonable, but let's go ahead and do that for now. In any case, I'm not sure under what circumstances I would want to go into this. I was basically, when I first did this, I was trying to do kind of error trapping, but it might be better if, for instance, if I'm not passing in new angle, rather than setting x and y to 0, it might be better just throw an error and say, hey, there's no angle here. Okay, in any case, what am I doing? I'm taking this dot x, I'm taking a new angle, and I'm taking the cosine and the sine times the magnitude. So this is going to give me the new direction, and to keep the magnitude the same, I just multiply the width of the horizontal direction and the vertical direction by whatever magnitude is, and that's going to give me, it's going to change whatever object this is, it's going to give it a new direction according to whatever this angle is. And then finally, let's go ahead and say set magnitude and set magnitude. Oh, this should be set dir. Let's be consistent here. So I've got get dir, get mag, set dir, and now I want to get, let's see, copy this. I want to go ahead and do set magnitude, and I will change that to set mag. And so in this case, when you set direction, you pass in an angle. When you set magnitude, you pass in. So this one, we're going to go ahead and get the angle. So we have already a get direction. Actually, we're calling that get dir. So we'll take in whatever object is using set mag. So vector1 dot set mag. We're going to pass in a magnitude, and it's going to set magnitude. So first of all, I'm going to get its angle, and then same thing here. I'm going to pass in the angle. I'm going to multiply it by whatever magnitude I'm sending in. So these two are very similar, and I didn't even bother to do the else thing down here. Let's get rid of that. And that is a big start on our vector class. The last thing I'm going to do is I think we used a distance formula in the other one. So we used this earlier, and we had to actually write it in to the code, and I believe it was the tower class. And so how do we find the distance? Well, to find the distance, again, I've got some vector object, and I say v1, let's say, dot dist, and this is going to simply return the distance between this and another vector. So let's go ahead and say I'm passing in a vector, and so all I have to do is find the distance between these two. So I'm going to say, let's go ahead and create a variable. So I'll say var dot x is equal to, and I'll say this dot x minus vec dot x, and same thing, I'll repeat this for y. So I'll take all of this code and come down here, and I'll say y, make a little temporary y guy, and say this dot y and vector y take their difference. And so now that represents the horizontal and vertical sides of a right triangle, and so all I have to do now is return, according to the Pythagorean theorem, I'm going to do math dot square root, and I'm going to take the square root of the sum of the product. So that's going to be x times x plus y times y, and according to the distance formula or the Pythagorean theorem, that should give me the length of that object. So that's the distance. And another one I'm going to have to do later on is normalize. We're going to be needing that, but I'll go ahead and add that in later. And so that's the good start on our vector class. I can start using vectors now just with this little simple bit of math, and I should say end JSVec class here, and that's good. We're good to go. Okay, I'm going to go ahead and stop this video here, and then we'll go ahead and start using this vector class in the next video.